Hello everyone, I'm Xiansheng Math, and in this video we're going to investigate how to convert a decimal, one that does not repeat but eventually, one that does not terminate but eventually repeats, into a rational number in fraction form. Alright, what does that mean? Well, here's a decimal, so one that does not terminate, that it means the decimal goes on forever. This is 0.7 repeating, and this just shows the sevens before indicating the repeating part, and same here. Okay, so here we have decimals, and this one does not terminate, but it eventually repeats, and we're going to change this into a number in fraction form. So what does that mean? Well, I'm going to start with 25 hundredths, which can be written as 25 hundredths in fraction form, and these two numbers have a common factor of 25, so I'm going to divide by 25 over 25, which is 1 in disguise, so I'm dividing by 1, and if you divide any number by 1, you get the same value back, you get an equivalent value. So 25 divided by 25 is 1, 100 divided by 25 is 4. So this is the idea, changing a decimal into a rational number in fraction form. This is a rational number because it's a ratio of two integers. 1 and 4 are both integers. Okay, so we're going to do this for a decimal that does not terminate. Okay, so we're going to use this form. I think it's probably the most illustrative for this particular case, and we're going to call this number and give it a variable name. We'll call it h. Okay, and the idea here is you want to get rid of the repeating part or turn it to 0, and this is the process by which you do that. So if this is h, if I multiply h by 10, I'll get 10h. And since I multiplied this by 10, I multiply this by 10 also. So the decimal will go one place to the right, and I will now have 7.777, and the 7 is gone forever. I'm also going to look at 100h, and that would move this decimal 2 places to the right. So that would be 77.7, 7 repeating, and 1000h. If I multiply h by 1000, I'd have to multiply this by 1000. That will move the decimal place 3 places to the right. And we get 777 and, or 0.777 repeating. Usually say and for the decimal, but there's no way to indicate the place value, so in this case one must say point. Alright, one thing I didn't do correctly was I need to get a visual on this is keep the place values aligned. So my 10h should look like this, 7.777, and I'll put another 7 here before the repeating. So that's my 10h. And again, place values should be aligned. So tenths with tenths, hundredths with hundredths. So and this would be 77. So that's 100h. And then 1000h. I'm scrunching things up. Sorry about that. All right. So now what I need to do is think about how can I get rid of the repeating part, because then I'll be able to show it's a rational number and write it in fraction form. Well, if I subtract h from 10h, I will get rid of the repeating part. So the idea here is I go 10h minus h, and that would be 7.777, repeating, and that's equal to an h minus h, which is equal to, and line up the place values. So if I look over here, I see if I subtract that, well, the repeating part was going to become 0 because this is the same as this, and then these are all the same too. So actually all of this, the whole decimal part, is going to become 0. The idea again is you want to make the repeating part 0. So I do this, I would get 10h minus h, which is 9h, and then these two parts are equivalent, so if I subtract something from its equivalent value, that becomes 0. So this is 0, so I'm just left with 7, and this is 9 times h. To undo multiplying by 9, I use the inverse operation of division, so I divide by 9, and I need to keep the balance, so I divide the other side by 9, and now I see, well, this is 1 in disguise. 1 times h is just h, and h equals 7/9. So now I see that h equals 0.777 repeating, and h also equals 7/9. So this equals 7/9. Okay, why did we do these others? Well, the idea is this is, using 10h and h is the simplest way to do it. But the idea being, to emphasize the point of you want to eliminate the repeating part or make it 0. So I could, if I wanted, let's say I look at these two, 1000h and 10h. Again, I see the repeating parts line up, so if I subtract this from this, 10h from 1000h, the repeating parts again will disappear. And we'll look at that. And this is to emphasize the idea. The way you do this is you need to choose the numbers that will cause the repeating part to be eliminated, become 0. So here I'm going to do 1000h minus 10h. What does 1000h equal? Equals 777.7777. Separate this a little bit. And 10h is equal to, and again I need to line up place values, so ones need to go with ones, tenths with tenths, hundredths with hundredths, and so on. And as I saw up here, I see here also that the decimal parts are the same. So if we subtract, we get rid of the repeating part. So this is going to be 0. So all we need to do is 777 minus 7. And what is that? That is 770. Over here, we have 1000h minus 10h, which is 990h. And I have 990 times h. To undo the multiplication, I use the inverse operation of division. So I divide by 990, and it's going to make the coefficient of h here 1. And then I divide over here by 990. And this is 1 in disguise, so you have 1 times h, and that's just h equals 770 over 990. And do these two numbers have any common factors? Well, in fact they do. We see they both end in 0, so that tells us they have a common factor of 10, so I could divide by 1 in the form of 10 over 10, and this would give 77 over 99, and looks like 11 is a common factor to both of these, so we're going to divide by 1 in the form of 11 divided by 11, and 77 divided by 11 is 7, and 99 divided by 11 is 9, and again we see that h equals 7/9, so 0.7777, 7 repeating is 7/9. This is the simplest, most direct way. The reason I did this was to show or explain the idea that the way to do this, there's no one single way. The idea is to eliminate the repeating part, and then you can show that this number is rational by showing it's a ratio of 2 integers. I hope you enjoyed this video and learned from it. If you did, please press like and subscribe. Thank you for watching. Xiansheng.